My fabulous chemistry faithful, video 12. We are almost done. Today we are going to look at the polarity of an overall molecule now. So this is not just bonds. Now it's all of the bonds put together. So there is a difference, and we do it completely differently. No END this time. We're not looking about the electronegativity differences between more than one atom. There are a few examples, so save some room. First, we have to understand what this whole asymmetrical means. Asymmetrical, of course, means that the molecule will fail the mirror test when I go north-south or east-west. It's not the same on all the sides. So any failure of this test means asymmetrical. And I didn't put it in the slides, but towards the end, I'm going to show you a acronym that a student came up with to remember this. So all right. So I will add that in with my writing. The molecule will not be the same on all sides. There will be a difference, and that's the key. So that's what I'm talking about. So here's an example. So first thing I'm going to do, I'm going to cut this north and south and check its east and west, right? So I check east and west, and it is the same on all sides. So right now I'm doing good. So far I'm passing, okay? But I got to do it the other way now. I got to cut it this way and look top and bottom, and now it's not the same top and bottom. So as soon as I have that not the same, boom, it's asymmetrical. See what I'm saying? Not the same on one side to the other. It's got to pass both sides. Now, symmetrical means it passes everything on both sides. It passes the mirror test on both sides. So I'm going to have very same sides passing the mirror test. It's going to be the same all the way around. When it's the same all the way around, then the molecule is nonpolar. Okay, so here's one. I got a methane. We'll learn how to name this way later. Cut it up and down. So east and west is the same side. Good. Cut it crossed horizontally, same north and south. So now that I've passed the mirror test both ways, now I am symmetrical. So once I'm symmetrical, I am nonpolar. Okay, so reiterating this, like dissolves like. Polar solids will dissolve in polar liquids. Nonpolar solids will dissolve in nonpolar liquids. So that's the like dissolves like that we will bring back when we get into solutions. The polarity of each must be the same, or the dissolving will not occur. Okay. Water is considered the universal solvent. This is the second time we've heard that. Okay. And ionics are polar by nature, so most of them will dissolve in water. We're going to learn in solutions to use table F to figure out which ones will and which ones won't dissolve in water. Okay. And now we have some examples quick where I have to draw them and then do their bond polarity and their molecular polarity. So I need table S. Okay, grab that. Make sure I have that handy. Table S, and then so bond polarity. So let's draw this thing. HCl is going to look like this. And when I cut it this way, it fails the symmetry test. So its molecule polarity is polar. But that doesn't mean it's necessarily the same for E and D. So I have to look them up, because then just the bond is, so hydrogen is 2.2. And Cl, I'm guessing, is 2.6. So the difference is 0.4. So this is a nonpolar bond. Well, it's 0.4. So it is. I think we decided that 0.4 is polar. So it's a polar covalent bond. Because that was 2.6. Okay. So next one, NH3. Got N. 3 H's. We just drew this in the other video, so I remember it. I don't have to redraw it. And then when I cut it this way, it passes, but when I cut it this way, it fails. So molecule polarity is polar. I need to do the END between one N and one H. So H again is 2.2. Nitrogen is 3.0. So this is a polar bond also. Okay, H2O. I know how to draw that. It's going to look like this. And when I cut it like this, it's not the same top or bottom. So this is a very polar molecule. This is the one where drawing water correctly helps me understand that it's polar. If I drew it incorrectly and drew it like this, then it would pass the symmetry test this way, and it would pass the symmetry test this way, and you would think it was nonpolar, and that's not the truth. Okay, so again, 2.2 for hydrogen. Oxygen is 3.4. So this is when I subtract these, this is a very polar bond. And it is possible to have a polar molecule with nonpolar bonds or a nonpolar molecule with polar bonds. They don't always jive. I just want you to be very clear on that. Because something like methane with a C with the four H's ends up being polar bonds, but because they are equal and opposite on either side of the carbon, it ends up being very nonpolar molecule with very polar bonds. Okay, so bond polarity, I know this is 0 because this is 3.4 minus 3.4. And molecule polarity, this one is going to pass this way, and it's going to pass this way, so this is nonpolar. So I just wanted to give you a heads-up example about how we can draw these to make sure we know the difference now between molecular polarity and bond polarity. So molecular polarity for ammonia has to do with the overall molecule's polarity, where bond polarity has to do with just the bond between two elements within the molecule. So I want us to be able to differentiate between the two separate videos, two different sets of practice. We have to understand that there's a difference. We got to read very carefully. Is it we're talking about a polar and nonpolar bond, or are we talking about an entire molecule? With that, we outie.